Hey Math 1100 students, this is our second lesson for Chapter 11 where we're still solving systems of linear equations, but this time we are going to be solving by a new method called substitution. The method that we're using, calling it substitution, is explained this way. First, we need to solve an equation, or one of the equations is going to be solved for one of its variables. Then we'll substitute that new expression for the variable. Since the variable and the expression are equal, we'll substitute the new expression for that variable into the other equation, and then we'll solve for the other variable. So here's our first example. We're going to solve the system x plus y equals 6 and y equals negative 3x. And conveniently, our second equation is already solved for the variable y. So we're going to use this to substitute into the first equation in place of y. So we're going to take x plus the value of y is negative 3x, and that's equal to 6. Well, x plus negative 3x is negative 2x, and negative 2x equals 6 can be solved by dividing both sides by negative 2. And that means we have x is equal to 6 divided by negative 2, which is negative 3. So at this point, we have found the value of the variable x. And we can use this to substitute into the other equation to figure out what y is. Therefore, y is equal to negative 3 times the value of x, which is negative 3. And that tells us then that y is equal to positive 9. Thus, we know that the solution to the ordered pair solution, to the system is negative 3, 9. Now, of course, we shouldn't ever just take that at face value. We should always substitute into the other equation and make sure that negative 3, 9 works in the other equation as well. So we'll check. And using x plus y equals 6, and substituting negative 3 for x and 9 for y to see whether or not those two add up to be 6. Well, negative 3 plus 9 is indeed 6. 6 is equal to 6, which is a true statement, and our solution checks. So here's another system. Looks like we don't quite have all of the equation there. I'll fill that in. And again, we're going to solve by substitution. Now, we can use either equation to solve for one of the variables, but honestly, it would be simpler since y has a coefficient of negative 1 here. It would be simpler to use the first equation and solve it for y. So in order to do that, we'll take 3x minus y equals negative 1. We will subtract 3x from both sides. And that will leave us then with negative y equals negative 1 minus 3x, or negative 3x minus 1. That's your choice. And then we will multiply both sides of the equation by negative 1. And of course, we know that negative 1 times negative y is going to give us positive y is equal to negative 1 times negative 1 will give us positive 1, and negative 1 times negative 3 will give us positive 3x, and we have an expression for y. So we will use that expression for y and substitute it into the other equation in place of y, which gives us 2x minus 3 times 1 plus 3x is equal to 10. So to simplify, 2x minus 3 minus 9x equals 10. We'll collect like terms. 2 minus 9x is negative 7x minus 3 equals 10. Then we'll add 3 to both sides. And we have negative 7x equals 10 plus 3 is 13, which gives us the first solution. X equals negative 13 over 7. And if x equals negative 13 over 7, we'll put that in for x in the first equation. So we will have 3 times negative 13 over 7 minus y equals negative 1. 3 times negative 13 is negative 39 over 7 minus y equals negative 1. We'll add 39 over 7 to both sides. And at this point, you can use your calculator, and you will have y, or negative y actually, equals negative 1 plus 39 over 7 turns out to be 32 over 7. So y will equal negative 32 over 7. And at this point, I would suggest that you use your calculator and the second equation and see if 2 times negative 13 over 7 minus 3 times negative 32 over 7 is 10. And I believe if you check that that is the case. So here's a recap of the substitution method. Using the substitution method, step 1 is you're going to solve one of the equations, your choice, doesn't matter which one, for one of its variables. Although I will tell you that a lot of times if you'll inspect those equations carefully, you'll see that one of them is easier to solve for one of the variables than the other one is. Many cases, you'll have one already solved for one of the variables, and that's the ideal time to use this method. Step 2, substitute the expression from step 1 into the other equation. Then step 3, solve the equation from step 2, and you'll find the value of one variable. Step 4, our next to the last step, says that we will substitute the value found in step 3 in any equation, it really doesn't matter which one, that contains both variables to find the value of the other variable. And the most important step of all is always step 5. Step 5 says you need to check the proposed solution. You need to be sure that it works. Because if you do all the work, and I'm going to warn you of this now so that you'll remember this for test, if you do all of the work and you've made an arithmetic mistake, you will get solutions, but they won't be the correct ones. And if you don't check that solution, you're going to miss that problem. So please don't think, well, I don't need to check my work. I'm sure this is right. That's just extra time I'll have to take. Take the time. People who check their solutions to algebra equations make better grades. So this is a really good study tip here. Step 5, you should always, always, always do step 5. That's a very important step. Here's a new system. Neither one of these is necessarily going to be easy to solve for one of the variables. Arbitrarily, since they're both, going to take several steps, then I'm going to arbitrarily choose the first equation, which is 3x plus 6y, is equal to 9. And I'm going to solve that equation for x. My first step in doing that is to subtract 6y from both sides, which will give me 3x equals 9 minus 6y. Then I'm going to divide 3x by 3, but then I'm going to divide both terms on the other side also by 3, which will leave me with just x. 9 over 3 is 3, and 6 over 3 is 2, so we'll have x is equal to 3 minus 2y. That is the expression that I will substitute for x into the second equation. And the second equation is 4 times x, which is 3 minus 2y, plus 8y is equal to 16. 4 times 3 is 12. 4 times negative 2y is negative 8y, plus 8y equals 16. But since negative 8y and positive 8y cancel out, this brings me to the ridiculous statement that 12 is equal to 16. That's not true. And when you get a statement where all the variables have disappeared, but the constants that you're left with are not equal to each other, then your decision about this is that there is no solution to the system. It would also be appropriate to say the system is inconsistent. Because it has no solution. If you wanted to verify that it has no solution, you could take the second equation and solve it for x, which would give me 4x equals 16 minus 8y, and dividing every term again by 4, the coefficient of x, I will wind up with x equals 16 over 4 is 4 minus 8 over 4 is 2y. And we notice we have a contradiction here because solving one equation for x says that the value of x is 4 minus 2y, but the other one says that x is 3 minus 2y. So there is where our problem comes in. You can't have x being the same as both of those expressions. Here's another system. I know how much you love fractions, and sometimes it is annoying to deal with fractions. So one of the things you might want to do using the substitution system is you can clear the fractions by multiplying by the common denominator. Preferably the least common denominator, which in this case is 3. That would give us 3 times 1/3 x minus 3 times y equals 3 times 2. 3 times 1/3 is 1, which leaves us with just x minus 3y equals 6. But here again, we run into a problem. X minus 3y equals 6 matches the other equation. And because those two equations match, that is going to be true for any value that fits in x minus 3y equals 6. So in this case, if we actually try to solve this system, and I'm going to show you what it would look like, since we have x minus 3y equals 6, that means then that x equals 6 plus 3y, and substituting into either of the previous equations, x minus 3y equals 6, and x is equal to 6 plus 3y minus 3y equals 6. When we complete our substitution, we have 6 plus 3y minus 3y equals 6. And of course, once again, 3y minus 3y cancels out. But this time, what we have is 6 is equal to 6. No variables. But, this is very important, 6 equals 6 is true. And that is equivalent to saying there are many solutions. because no matter what I would put in for x and y, as long as it checked in both equations, then that same solution would also fit in the other equation. This completes our lesson for section 11.2 on using the substitution method. Please be sure and review these notes, and in particular realize that when you get a statement like 6 equals 6, that is a true statement, which means you'll have infinite solutions. True meaning there are solutions, infinitely many, because we can put in anything we want to. But if we got a statement like we did before, like 12 equals 16, that's not true. And when we have a statement at the end that is not true and there's no variables left, that means there is no solution.